Hi, good morning, everyone. Thank you so much for being here. And I know if you're anything like me, you've had a massive queue of traffic to get through to get here. But we're here now, so let's get started. So I'm going to start off with a little bit of background about myself. I grew up in India, where it's really quite normal for girls to like maths and physics, and all of us study it together with the boys, and we're all great at it, and it's all fine. I then decided to come to the UK to study my A-levels. So I did maths, further maths, physics, and design technology. And then I was thinking to myself, what do I do with myself? What job do I want? What career do I want? And no one thought to say to me, you've got the perfect A-levels for engineering. Have you considered that? So instead, I thought, slightly geeky, but I love physics. I'm really good at it. I'm going to study physics at university. So that's what I went off and did. And then I was really lucky to get a work placement with some engineers. So my job was really boring because all I had to do was go around the university department and map out all the fryer sprinkler systems and the extinguishers and so on. But what it did expose me to was some really brilliant engineers that were designing particle accelerators at CERN. So if you heard about the Higgs boson that was discovered in Switzerland and France recently, they were designing things like that. And I just thought that's absolutely amazing. They're using maths and physics to design sort of real practical things, really, really exciting stuff. So I then decided to do a master's in structural engineering at Imperial College in London. And that's how I've become an engineer. So hands up, who knows what engineering is? Who's heard of engineers? Who knows an engineer? No one? No one's ever seen an engineer before? Well, all of you can put your hands up now because I'm an engineer. So you've all met one now, finally. Great. So what I want you to think about is when you wake up every morning, you wake up in your house. Why isn't your house collapsing down on your head? Why is that a safe place to be? Why is it warm? You've got radiators there. How is that water coming in? When you go to brush your teeth and have a shower, where is that water coming from? Why is it safe? Why can you drink it? And where does it go once it goes down the drain? And then you have some breakfast. Where does that food come from? How has it got to your table? And then you get into your car or your train or your bus to get to work or to school. And who's designed that? So really, engineering is behind every single thing that we use and that we do. Every man-made object, your iPhone, your clothes, your glasses, everything has been designed by an engineer. So that's pretty exciting stuff. What's even more exciting is if you think about what the biggest challenges are that humanity faces today. Does anyone want to be brave and shout out a few answers? What are the big problems that we face? Yeah? Water, thank you. Food, absolutely. Power, that's brilliant. I think you've pretty much covered all of my points. Who do you think is going to solve these problems? Anyone? Engineers, thank you. So my point is that engineering is a really exciting field to be in because you're going to take these problems, you're going to break them down, and you're going to solve them. And if you're passionate about helping people, then engineering is an amazing career to have. Okay. So, if I can get all of you to close your eyes, please, for 1 second, and then I want you to picture an engineer. So I've already had 0 hands up when I asked if you knew an engineer, but if you picture what you've got in your head for an engineer, and then you can open your eyes now. Okay, how many of you pictured something like this? No, okay. So these are all terrible stereotypes that we need to get rid of because engineers are a really diverse bunch of people. Like I said, I'm an engineer too. So that's a picture from my office. And as you can see, we're all a very happy, excited bunch. We work with computers, we work with other people. We sometimes go on site because I'm a structural engineer. I work in the construction industry. And it's really exciting. So does anyone know which building that is? So that is the top of the Shard. That's the highest level of the Shard. And there's a very proud team of engineers there that all contributed to that. Now, what does structural engineering do? So I've just described all these different types of engineering and how you can get involved in lots of different stuff. But I'm a structural engineer, so I kind of work in a tiny little part of the whole kind of spectrum of engineering jobs. So what is it exactly that I do? So when I talked about your house and why it's not falling in your heads, that's because a structural engineer has designed your house to make sure it's safe. So we work with bridges and buildings to make sure that they stand up, that they're safe, and that they're comfortable to use. So we need to make sure that tall buildings don't sway too much, because otherwise you might feel a little bit seasick. We need to make sure that your office floors or your school floors are not vibrating. And obviously we need to make sure that they don't fall down. So that's my job. And what does that mean? So what do I actually do every day? We work with architects and other designers. They come to us with a picture and they say, here's this amazing idea we have for a building. How are we going to make this stand up? So I spend time with them going through their sketches and trying to work out where should we put the columns and the beams and the frames to make it all safe. So I do lots of sketching, lots of brainstorming, putting ideas together. It's very, very creative. We work in teams. No building can be put up without mechanical engineers to do all the air conditioning, electrical engineers to give you light, the public health engineers that do the drainage so that the water comes in and out the building safely, and of course the structural engineers that actually make sure it stands up. So we all work together in a massive team to do that. We also do a bit of work on site, as I mentioned, but I really love going on site because that's an opportunity for me to see my work being built and something real's come of it. So I deal with drawings in the office, but when I finally get to site, I can see those drawings built real, and it's pretty amazing. And recently, I've been trying to do lots of outreach work as well to tell everyone what engineers do and who we are. So next time, hopefully, somebody asks you a question about engineering, you can put your hands up and say, I know what engineering is, and I know what they look like. So I'm going to tell you a little bit about the Shard. So how many of you have been to London and seen it? Hands up? Yeah, a few people? Excellent. Well, that's what it looks like at night. Very impressive. And I'll tell you a little bit about my personal involvement, but I also want to highlight to you, because I said that engineering is creative and it's collaborative. That means we come up with new ideas and ways to do things, and we work with people. So can I give you real examples to prove that to you now? Okay, so the foundation. The foundation is what's at the very bottom of a building to make sure that all the weight and load coming down the building goes safely into the ground. So if a foundation goes wrong, if it doesn't work very well, you get something like the Leaning Tower of Pisa. That's why that's kind of leaning over, because the foundation's settled and it's not doing very well. I also designed the spire, which is the very, very top of the building. So if any of you have been up to the viewing platform, that's the spire, that's in the spire. It's a really exciting bit of structure. It's great for us because you can see all the steel, and I love that kind of thing. It's not covered up with any boards or architectural finishes or anything. And I also looked after a lot of the construction phase. So as I was telling you, it's really great to see stuff going on site, but every so often you can get unexpected problems. So for example, on the Shard, we found when we started doing our foundation work that there was a massive geological fault on the site. So that means that the soil kind of started off up there, and then it kind of went down, and then it went that way again. And so we had to go back and check all of our designs to make sure that everything still worked. And it did, so that's good. So I'm going to tell you about the foundation first, which was a really exciting part of the building to be involved in. So that's what the foundation looks like. Over here, where we've got this big green bit in the middle, that's the sort of the spine of the building, or like the trunk of a tree, which makes the building stable. So if you imagine all the wind from the storm that we had a few weeks ago hitting the side of the building, it's that piece of concrete which goes up all the way through the tower, and it makes sure that the building is nice and safe against the wind. Then we've got this big gray slab, and that's what we call a raft. So that's a big, thick concrete slab that's 3 meters deep. I'm about 1.5 meters tall, so that slab is probably as high as this stage is. And when it was being constructed, I went and kind of stood inside the slab, obviously before they started pouring the concrete in. Around the wall, you can see that there's this red piled wall, and what that does is it enables us to dig into the ground. So if you want to make a basement, you need to keep all the earth out, and you need to keep all the water out, because there's lots and lots of water in the ground, which will come pouring into your basements if you're not careful. And then these orange sort of shafts down here are what we call piles. They're made of concrete, and what they do is we drill them into the ground, we fill them in with concrete, and that takes all the load from the building and disperses it out into the ground, and that's what keeps it nice and stable on the ground. So the challenge we had was we needed to build this really, really quickly, because time is money. Cranes cost lots and lots to rent on site, and so the client said, how can we do this quickly? And so we came up with a very, very interesting idea, which is something that has never, ever been done before in the whole world. Well, I'm not sure about the whole world, but definitely not done in the UK before. And what we did was to start at ground level, which is kind of where that grey beam is, and we built upwards and downwards at the same time. So we were building a building without the foundations being complete, which is slightly scary perhaps, but it all worked out brilliantly. So what we did is we used these, what we call steel plunge columns. We put them into the concrete piles. So we put those down in here. And what those did was to support the rig, which would build the core. So then we started pouring concrete. So we put our ground floor slab in. So you can see that over here. And then we started digging underneath it. And we made a big hole. And then this slab is now supported by lots of columns like this. Those columns in the middle, the reason there's a big hole in the middle is so that the concrete core can now be built. And then, so that big black banner you see there, which says shard, is called a slip form. And what that does is like a giant cookie cutter or a template that you pour concrete into, and then you move it up, and then you get the shape of the concrete that you want. And so that core was supported off these kind of steel columns. So this is my favorite picture of the shard. And you're thinking, what are you talking about? It's a terrible, dungy picture from the basement. But in engineering terms, this is the most exciting part for us. Because what we've got here are those plunge columns that I talked to you about. These are the top of the concrete piles, and you can see the bottom of the concrete core. And that core was 20 stories high, just supported on those stilts, with no foundations below them. So that's pretty exciting stuff. And by enabling this, by doing this, we could enable the contractors to build up and down at the same time, so we saved many, many months on the program. And we got to do some cool engineering as well. And that's what it looks like as it goes up. So you can see all the floors going in here, and they get connected to the core, and this provides all the stiffness to the building. I'm going to give you a second really quick example about how we use creativity to build things. So the spire, as I mentioned, is at the very top of the building. And if you go to the viewing gallery, you'll be standing in here somewhere. And all of this above you is another 20-story building. Big steel thing. So you have to ask yourself, so designing it is one thing, but how are you going to build that? You're in the middle of central London. You've got lots of traffic around you. There's a hospital across the road. There's a Jubilee Line tube tunnel in the ground next to us. And we've got all of these historic arches all around us. What are we going to do? How are you going to build that? So my idea was to get a helicopter to put the entire thing on the top of the building. But unfortunately, it's a bit heavy to get a helicopter to do it. So sadly, we had to do it in pieces. So we used a crane. So I'll show you some of the views. So if you haven't been to the viewing gallery, this is the sort of thing you can see. Now, this is what an engineering drawing looks like. I've taken off all the text and all the numbers, but all of these lines are the steel beams. And what we did, normally, you lift in one beam by a crane, and then you bolt them up. And then you lift the next one up, and you bolt it up, and you keep going. Instead, what we did here was to break it up into modules. So we built all of that in a factory, all of that in a factory, and then we picked up the whole thing in one lift and bolted it all up together. Now, the advantage of doing that is that the number of times the crane has to go down to the ground and then go up 300 meters is greatly reduced. So the other thing to keep in mind is when you've got lots of wind, the cranes can't work, like they can't lift things up. Because if you imagine that the crane's kind of picking something up and it's windy and you've got a glass building right underneath you, that's probably not such a good idea. So we lose 70% of our day is lost because of the wind on a crane. So we did all of this, and then the things that dictated to us how big these modules could be was the weight. So it depended on how heavy, what the crane can lift. And it also depended on the size of a truck. Now that's a slightly unusual thing. But we had to get these pieces of steel from Yorkshire down to London. And you don't want to have a truck that spans 2 lanes because you'd get in all sorts of trouble with the police. So we had to size all of them so that they were small enough. And then we built it all up like that. So we also did mock-ups of the entire spire up in Yorkshire before it was actually built in London. And the reason for this was to make sure that everything fit together. So if you imagine you're putting together a Meccano set or a Lego set, you can do a little test run on the ground before you bring it to London and put it on top of the shard. So that is a picture of the very, very top of the building. So if you remember that team shot that I showed you before, we were kind of sitting in here somewhere, but actually on the top of the shard, not in this field. I wouldn't want his job because I'm terrified of heights, but these guys absolutely love it. So that's the very, very top of the shard. That's a picture of the very last piece of steel going in. So, why do I think that everyone should study engineering? If you love maths and science, it's a great way to do practical things and to really, use your skills to, design stuff and make real objects out of it. It's creative. I think it's creative because we have to come up with lots of different ideas about how to build things and how to put things together. And that to me is creativity. You get to work with people. I'm not the kind of person that can sit behind a desk hiding behind a computer all day. I need to be out there talking to people and enjoying myself, and that's what I get to do. And finally, there is no satisfying feeling like the one where you can stand and look at a building or a bridge and say that I did that. So I'm just going to very quickly tell you about a few different ways you can get into engineering. So you could do an engineering degree. That's the kind of obvious way. That's what a lot of people do. Or like me, you can do a science degree. And then you can do a master's in engineering or training in engineering. So that's another slightly different way to go about it. You can also do an apprenticeship. There are loads and loads of apprenticeships available in all different types of companies, and I'm sure you're going to find out about them from lots of different companies today. And they're a great way. When you're 16, you can go into the workplace, learn hands-on, get a degree while you're at it. Great way to do it. And there's also technicians. So it's not just engineers that put building together. We need people to draw it for us. So we do lots of 3D modeling, and it's the technicians that help us put all of that together. So if you love drawing and you love putting models together, that's a great thing to do as well. That's all from me, and I think we might have a few minutes for questions, hopefully. Thank you very much.
So, does anyone have any questions on how the shard was built or anything? No questions? Okay.
How long did it actually take to build the shard from start to end?
So the shard is one of the really long projects. I spent 6 years of my career doing it, but luckily because there were so many different things to do, I kept doing lots of new stuff. So we started demolition of the building on the site in 2006. So overall it's been about 5 years to get to the structure finishing, and then once that was done, you have to do all the fit out inside, so you put all the air conditioning ducts in, and all the carpets and all of that kind of stuff. So we're still working on it. So it'll probably be about 6 to 7 years in the end. Thank you.
Any more questions? Oh.
Is the shard bigger than the Burj Khalifa?
Unfortunately, it's not. So the Burj Khalifa is the tallest building in the whole world, and it's probably about 3 times taller than this one. But we're very proud of the shard because it's in the UK, and it's the tallest building in Europe.
How much did cost?
I don't actually know the final numbers, but it was in the range of sort of 400 to 500 million pounds. And that's including like the regeneration of the whole area, because there's a new bus station going in, the station's been redone as well. So it's a big project. It's not just the tower that I've talked about today.
If you do the apprenticeship, can you do the degree at the same time?
Yes, you can. So I don't know exactly how it works, but you can start off doing an apprenticeship. And I think for the first 2 years, you get lots and lots of experience. We have quite a few apprentices with us, and they're on day release for doing a degree. So they work 4 days a week, and then they're out for 1 day at university. And then often they also take like 2 or 3 weeks off to go to university. So I think it's fairly flexible in the different types of courses you can do. I think, was there a question here?
Is the project on time?
It is. So we wanted to finish the whole outside of the building before the Olympics, which we achieved. And we've handed the building over, and now it's really with the guys that are going to move into the offices and the hotel, and they're just fitting things out. So to be honest, our involvement is pretty much done, and it was all done just before the Olympics.
Okay, is that all the... Oh, we're here.
How many piles were needed for the shard?
That's a very, very good question. So I think there's about 140 piles underneath the main kind of foundation slab, and then the wall that I showed you going around it has another 200 piles or so. So there's lots and lots of piles in there, and they were about 1.5 meters in diameter. So if you imagine me lying down on the stage, that's how big they were. So they were pretty big things.
Okay, so we've got a question over here.
Thanks very much for your brilliant talk, by the way. Just to ask, what's the difference between a structural engineer and a civil engineer?
That's a very, very good question. So civil engineering covers a wider range of different types of engineering. So you can learn how to do highway design, infrastructure design, which is like big bridges and so on. You learn about kind of underground drainage, so how to build kind of massive tunnels and sewers, which I know doesn't sound very exciting, but tunnels are pretty exciting. And so you do quite a big range of things. Structural engineers are a kind of a subset of that mainly specialize in designing tall buildings or buildings and bridges.
Okay, so that's all we've got time for. Thank you very much. Can we have a big round of applause, please?
Thank you very much.